Welcome. In today's video, we're going to look at the characteristic function of the binomial distribution. So, as a refresher, recall that if x has a binomial distribution with parameter n and p, or parameters n and p, then the probability mass function, or the PMF of x is, and we'll write px of x is equal to n choose x p to the power of x 1 minus p to the n minus x, and this is true for any x values which are in the support 0, 1, 2, all the way up to n. Now, the characteristic function, which we write as this, typically var phi x of t, is by definition the expected value of e to the I tx. And in this case, it is a discrete random variable, so this can be expressed in the form x in the support of x, for we sum across all x in the support of x, of eitx multiplied by px of x. Now, the support of x, as we said, is the integers 0, 1, 2 up to n, so we can change this summation to x equals 0 to n. The e to the I tx stays the same, but we're going to replace our expression here above that we have. We will replace that with nx p to the x 1 minus p to the n minus x. Now, the next step in this computation is to recognize that this e to the I tx and this px can actually be combined. In particular, they can be combined in the following way. So I'm just going to rewrite this, and I'm going to, instead of rewriting eitx, or e to the power of I times t times x, I can actually rewrite this as e to the power of it all to the power of x using my power laws, and then I'm still going to multiply by all the other parts in this expression, n minus x. And then by the power laws, I've got something to the power of x and something to the power of x. This means that I can take x equals 0 to n, and I can write it as p e to the I t all to the power of x. And I'm going to put the n choose x out the front here, and I'm going to still have my 1 minus p to the n minus x here. And what we recognize this as is, we could see it as this expression here, x equals 0 to the n of n choose x of a to the x b to the n minus x, where a equals p e to the I t and b equals 1 minus p. And what you might recognize here is that this is actually the expression for the expansion of the binomial, is the expansion for the binomial, which looks like this, a plus b to the power of n. In other words, we're actually reversing the binomial theorem, because the expansion of a plus b to the power of n is equivalent to this. And now, using our values of a and b that we previously defined in the equation above, we can resubstitute those in, so it becomes 1 minus p plus p e to the I t to the power of n. And that is the characteristic function for the binomial distribution. Thanks for watching. See you in the next video.